Today, we talk about construction management and infrastructure sensors and how they're benefiting the construction industry. I am your host, Brian Wagner, a licensed professional engineer, and in this episode of the Engineering Quality Control Podcast, I'm talking with Eric Van Dixhorn, Technical Sales Manager at Brickeye, a leader in industrial IoT and data analytics for risk mitigation. We'll be discussing the advantages and disadvantages of concrete sensors, their use in mass concrete thermal monitoring, and the benefits of environmental sensors on your job site. So let's jump right in. So now I'd like to welcome our guest for today, Eric Van Dixhorn from Brickeye. Eric, welcome to the Engineering Quality Control Podcast.
Thanks, Brian, for having me. Looking forward to it.
So welcome to the show. And if we just get started, could you tell our audience a little bit about yourself, maybe what you do on a daily basis and what your interface is with engineering?
Yeah, of course. So my background is in civil engineering. I attended the University of Wisconsin in Milwaukee, and then went to work as a project manager for almost 8 years for a heavy civil contractor in the Wisconsin area. So mainly worked on bridge construction, heavy highway, a lot of road construction. So about 4 years ago, I was invited to join a small startup called Nitrocrete, and Nitrocrete developed this innovative technology that used liquid nitrogen for cooling ready-mix concrete. So that brought our family out to Colorado. So that was a really good experience, a lot of fun. For the last year and a half, I've been working for Brickeye. So Brickeye is a Toronto-based company that works with IoT technology in the construction industry. So my role, I'm the director of technical sales. I lead sales and business development here in the United States, mainly with our concrete sensors, which is part of our Lumicon brand. So yeah, it's been a lot of fun. It's a really smart group of people that I'm working with. They've been great to work with. So yeah, it's been a really good fit.
That's great. So it's funny, and not necessarily funny, but it's nice to hear how everybody's career path is so different. And somebody that starts out in a land development realm that ends up in a heavy construction or vice versa, or going from different aspects of engineering. Civil engineering is such a wide range of skill sets that are so blended and meshed together. There's so much autonomy. And I think we've really seen it recently, but it's nice to hear when people kind of, I don't want to say bounce around, but change that path to find something they really like.
Yeah, it took me a while to finish school, and that's mainly because I couldn't make up my mind on what I wanted to do. So I actually started out in a small liberal arts college, pursuing more of a communication. I think then I switched over to economics, and then realized, no, I want to do construction. So as I got into my degree, I'm like, I really like structural engineering, so I'll focus on that. And then once I got out of school, I'm like, I don't want to sit behind a desk all day. So then I kind of reverted back to construction management, and so yeah, I've bounced around quite a bit.
Right. But all that experience benefits you, right?
For sure, it's been really good. Yeah.
So I want to talk more about the concrete sensors today and what quality advantages that technology brings to the construction world.
Yeah, so I mean, typically, like if you're trying to determine the early age strength of concrete, the kind of the most common way of doing it is you make a set of cylinders, you place those next to your pour, and then in the approximate time frame that you think that they are ready and they meet the strength that you need, you'd have those cylinders tested. And if they meet that strength requirement, great, you're good to go. If not, well, maybe test tomorrow and try again. So the main issue with this approach is that the strength of concrete is directly related to the temperature of the concrete, at which temperature it is curing. So if you can imagine concrete that's curing at 120 degrees Fahrenheit is going to gain strength a lot faster than, say, concrete that's curing at 70 degrees. So, and if you picture, a concrete pour, a large mass, it's going to generate a lot more heat than the little cylinder that is placed right next to it. So there's a big discrepancy between the temperature of your sample and the temperature of your in-place concrete, which also means there's a large discrepancy with the strength. So that's where what we call the maturity method comes into play. And the maturity method is an ASTM standard. And it essentially says that if you can monitor the temperature history of your concrete, then you can very closely estimate the strength. And it's a very accurate method. It's been around for many years. It's accepted by most DOTs. It's encouraged by ACI and most specifications. So the use of sensors allows you to use this maturity method. And from a technical standpoint, that's the advantage, is that you get a much more accurate estimate of your concrete strength. But even from a practical standpoint, I don't have to call up the testing firm, say, hey, can you go pick up the cylinder? They grab it, they take it back to the lab, they test it, they say, yes, you're good, or no, sorry. With sensors and IoT sensors, you can see real time what the strength of your concrete is. So just a lot of benefits to it.
I can't tell you how many times I've seen those sensors, or not sensors, but the cylinders get picked up the same day as the pour and taken with the inspector to somewhere else too. That they don't necessarily always stay on site.
Exactly. Yeah, and there's different types. So the maturity method doesn't necessarily replace your 28-day strengths. Like those are still required to make sure that your concrete meets the design strength. But it's those early age days where if you want an accurate representation of your concrete in place, using the maturity method is much more accurate.
And then you can know when you can continue the construction process.
Exactly. So it's used very often in concrete pavement. It's used a lot in post-tension decks where you really need to tension those strands at the right time. So that's where maturity method is often used. Mm-hmm.
So are you also using sensors like on the job site, like environmental sensors?
Well, so the concrete sensors are mainly used for, I'd say, two reasons. One is a maturity method. The other reason is for mass concrete applications. So mass concrete, it's defined as any type of volume of concrete that the temperature development or the heat generation of it may cause durability issues and cracking. So if you have a mass concrete placement, and ACI doesn't really define what exact dimension that needs to be, but typically, if your placement is 3 to 4 foot thick, it would start to fall under mass concrete. I've seen some placements that are thinner if they have a higher cementitious content, but that's generally what I've seen is kind of that threshold, is around 3 to 4 feet. So if you have mass concrete, you would have a thermal control plan. And the thermal control plan is essentially an action plan that would help minimize the temperature gain and the temperature differentials within that pour. So as part of that thermal control plan, these sensors would help monitor your temperatures within the pour, and then whatever differentials are happening within it as well.
And what kind of data are they feeding? Just temperature or?
For mass concrete is just temperature. That's correct. Yeah. Mm-hmm.
So what are some of the key challenges associated with implementing these IoT sensors on construction sites?
Some of the challenges are just, I think in general, like there are exceptions, but the construction industry is generally not seen as very progressive. So it's been done this way for so many years. Why change anything now? So I think that's why some people look at this new emerging technology as like, why do we need that? Another reason is just in the construction industry, the profit margins aren't as high as other industries. So you kind of couple the this is how we have always done it approach to margins being not that high. And maybe these sensors and IoT technologies viewed as kind of a nice to have, but not a necessity. So I think for those reasons, often they don't get used when they should.
Do you have any advice for somebody that's like, I really like this technology, or I've learned about it through whether they're listening to this podcast or some other thing, and how to maybe approach their supervisors or their leadership on the concepts like resources?
Yeah, I mean, I think my recommendation would be to start small. Like don't jump in the deep end with it. Figure out, like, based on your project and what you're doing, where it may make sense and where it doesn't. So kind of a little bit of a side note, but in addition to our concrete sensors, we also have kind of a whole variety of environmental sensors as well. And those are mainly used for risk mitigation purposes. So these include like weather stations, it might include noise monitoring, air quality, vibration monitoring. One of the biggest ones is water leak detection. So if you have a project where you're worried about some of these risks, it might be a good idea to start implementing them on, as a pilot project, as a test. Talk with other contractors that may be using them, pick their brains on what works well, what doesn't. Start talking with vendors and suppliers that provide these types of services, so you have an idea on some of the costs and implications with using them. But yeah, that'd be my advice, is to kind of start small, start with some pilot projects and test it out.
I think it's great advice. I think it's great technology. And actually, even if you listen to the last few episodes of the podcast, we've really been talking a lot more about technology and apps and systems that help improve the overall quality of the finished product, whether it's on the construction side, on the engineering and design side,
Yeah.
or the implementation and execution, whether it's construction inspection and those things. So, how do you see these sensors and this technology fitting into the broader trend of digitalization in the construction industry? And where do you think the future of the industry is going to go? Maybe a little foreshadowing based on your experience.
Yeah, that's a good question. I mean, and it's fun to see. I mean, you nailed it. Like that's where the trend is going. I really enjoy looking at a lot of the new technology that's out there. From using drones for like inspecting bridges. I just saw a video on this new technology where they're using digital mapping of utilities to essentially limit how far an excavator can move. So if the bucket of the excavator is approaching this utility based on the GPS data, it would physically restrain the operator from being able to move that bucket any closer. Um, Another example is just from my bridge construction background. I remember once the bridge deck is formed up, kind of the next step in the process is having the rebar placed. And I just remember looking out on a deck and you see 10 to 12 iron workers out there, and they're bent over doing this 8 to 10 hours a day, 4 to 5 days of work on each bridge deck, depending on how big it is. And it's like, man, there's got to be a better way to do this. And recently I saw this kind of newer technology. I think it's called TieBot, where it's a robot that pretty much grabs the rebar, places it out there, and then goes ahead and ties it. So it's been really fascinating to see some of the newer technology and newer trends that are happening. But yeah, I think it's headed in that direction. I recently saw a survey of a number of construction executives and owners for contractors, like what is their biggest concern, what is highest on their worry list. And without a doubt, the highest on the list was the labor shortage. Just finding people to do the work. There's plenty of work coming through. There's plenty of equipment to be able to throw at the project, but it's finding people to do it. I just had a conversation with a client of ours in North Carolina. They're doing a wastewater treatment plant, and they're ready to start the job. It's ready to go, but they can't find people. They don't have a crew to put on the job. So this has been just a common theme that I've noticed in the last few years. So I think that, I talked about technology kind of being a nice to have. I think it's going to quickly transition into being more of a necessity. You're going to have to be able to do more with less people. And I think that's where technology can kind of fill that gap.
And I think my son is in Cub Scouts, and
Okay.
when I was in Scouts 25 years ago, there was a whole bunch of people and a whole bunch of parents that were very willing to help.
Yeah.
And when you said that do less with more or do more with less people, I feel like every volunteer organization in the country
Yeah.
is dealing with that, whether it's the volunteer fire department or the volunteers that are leading Cub Scouts and Boy Scouts and even church groups and all of those different things, because we are so busy in life.
Yep.
And if one good thing, in my opinion, that actually did come out of COVID was the realization that I think a lot of people kind of hit the brakes and check themselves onto how they wanted to live their life
Right.
and what technology can be leveraged. I mean, how many people are working hybrid in the design side of engineering now, and
Yep.
that you can have a meeting with somebody on the other side of the planet
Yep.
and get work done. Like that, the technology and the proliferation of that technology and the ideas that are coming about are fun to watch, like you said.
Yeah. Yeah, it's true. COVID had a massive influence on technology. So for any kind of tech startups that were working in the construction sector when COVID hit, it was a good time for them. But no, it's true. I mean, I remember having to travel a lot more for work, and like you think about it, like yeah, if you have a meeting down, if I had a meeting down in Texas, yeah, it makes sense. You book a flight, you head down there for the day, have your 2 hour meeting, and you're then maybe stay the night and back home the following day. Well, if you think about, like, if you add up the hours that you're on the road, if you add up the cost of your not just the flight, but your time associated with the travel, like it adds up. Now that becomes a $2,000 meeting that you just went to, when you could probably accomplish the same thing over a Zoom call in 1 hour. So, I mean, there's certainly advantages to doing things face to face, but I think in many ways it's been a good thing to see some of that shift happen.
So you mentioned risk, and that's, I mean, quality of work is mitigating risk. You're trying to minimize cost overruns, increase profits, maintain safety amongst everybody working on a job site or anybody in the process of engineering. And you touched on the labor force or lack thereof.
Yep.
Where do you see your sensors and the technology that you are working with helping those two things?
Yeah, that's a good question. So I think from, I guess, our environmental side of the business, one of the sensors that we've been seeing a lot is our water leak detection. So just kind of a personal example, wasn't this past Christmas, but the one before that, our family headed back to Wisconsin to see just family and friends, and I've installed little water sensors around our house just to track if we have any leaks. And sure enough, I think it was the day before Christmas, I'm getting an alert on my phone that the sensor underneath our kitchen sink was detected water. I'm like, what's going on? So I call up my neighbor. He heads over to our house. He's like, calls me. He's like, "Yep, your faucet is leaking." So he shut off the water and all good. But just thinking through what would have happened had I not had that in place, like we would have gotten home and we would have had an entire basement, drywall damaged and hardwood floor damaged, and thousands of dollars later. So that kind of hit me, like, this small, maybe insignificant and little sensor really helped mitigate a lot of risk and issues. So if you think about that just on a larger scale with large, let's say, high-rise project that has temporary water runs, and especially in climates where you're seeing a lot of freeze thaw cycles, just being able to have that peace of mind that if something bursts or something leaked and you have water building up in an electrical panel room or something similar, um, that someone would be notified, and you can take kind of this proactive approach to mitigating that risk, to turning that water off, versus showing up on Monday and you have a major headache on your hands. So that's one area. The other area with more of the concrete sensors, I recently had a presentation with the Concrete Association of Wyoming, and WYDOT is one of the few states that hasn't quite accepted maturity yet. But they're leaning towards it. They're moving towards allowing it because, kind of similar to the labor shortage, they can't find people. They can't find people to make the samples and then to pick up the samples, and maybe the contractor wants to work on a Saturday. They can't find people to pick up these cylinders, take them to a lab on a Saturday and break them. So they're very adamant about kind of addressing that labor shortage with the use of technology. So it's going to become more and more common. Definitely. I think the contractors that aren't using it, that's going to start to become the exception. So
I think it's a ton of great information. And I do want to be courteous of your time, so we could probably talk for hours.
yeah.
But and maybe this isn't, I know we talked about the future of construction and engineering and things like that, but do you see any state or any organization that's really on the cutting edge ahead of everybody else that you think is going to kind of help spur on adoption or the implementation of different standards?
Yeah, from a I guess from an infrastructure standpoint, I mean, two states that stand out to me. One is Utah, especially from a bridge construction standpoint. I think they've been a state that has really adopted what they call ABC, accelerated bridge construction. So they've just implemented some really cool technology to just minimize the disruption to the traveling public. So methods for building bridges really quickly and getting them in place. If maybe it means building them off site and moving them in place like over a weekend. So they seem to be kind of on the cutting edge of that type of technology. But believe it or not, Iowa is actually from a concrete science standpoint, I'd say they are one of the ones at the forefront. I think they self-describe themselves as the concrete state, or I'll have to look up what they actually describe it as. But yeah, Iowa is very progressive when it comes to different technology within their concrete pavements, concrete bridge decks. They've done a lot of cool things. And I mean, from like other technology standpoints, it's interesting. I noticed this maybe more so when I was at Nitrocrete. There's certain states and certain industries that are more open to, I guess, what I'll say, paying premiums for some of this added technology. So cooled concrete. In Toronto, it was a big deal, and customers didn't have any concerns with paying some of these premiums for that added benefit. I saw the same thing in like the Mid-Atlantic region, New York, saw some of that, where, as an example, down in Texas, Oklahoma, it was kind of a different approach. There's less openness, excuse me, to kind of paying some of these premiums for some of that technology. So it was interesting to see how in certain areas, just the value of technology and some of the benefits is definitely more prominent than others. Mhm.
Right. I think we've shared a ton of great information, but I do want to transition to what we call the power of experience segment. And maybe it's some aspect of your career, like we talked, like you took a not a direct path to where you are. So you've bounced around a little bit to different things, whether it was in college or in your professional career. But do you have a piece of advice that you'd want to share with our listeners that can be completely related today or completely not related to what we've been talking about that you just want to share with somebody that's in this industry?
Yeah, that's a great question. Actually my my wife and I were just kind of talking about this the other day. So I've been out of school for 13 years, and looking back, I think I would have placed a higher emphasis or priority on, especially in those first few years out of school, on not taking kind of the safe and traditional route. So we got married pretty young. We were both in school, and so we did not have a lot of money those years when we were finishing up school. So I think once we graduated, she's a physical therapist. We were both just very eager to make money and buy a house and get a dog and do all those things you're supposed to do when you when you grow up and get a real job. But looking back, I think I would have enjoyed taking maybe a few more risks with my career. Maybe traveled more, found a position where I could bounce around a lot, just experience new things, see different types of construction, meet new people. So like all these things, just your tolerance for risk lowers, and it just becomes more difficult once you have kids and a mortgage and bills to pay. So I think that would be my advice for someone that's just starting out is don't take a job for the money. Don't take a job because it's safe. Don't take it, because it's what people expect you to do. Like that is the point in your career where you should be not playing it safe. So try new things, figure out what you're good at, figure out what you're bad at, figure out what you're passionate about. Um, when you're young, that's the time to do it when the stakes aren't quite as high.
Great advice. So thank you for that. Uh, what is the best way for somebody to get a hold of you if they wanted to continue this conversation?
Probably through LinkedIn. So I think I'm guessing my name will be posted to the notes. I have a pretty unique last name, so I'm not hard to find. Otherwise, my email is eric@brickeye.com, so it's pretty easy to remember as well. So yeah.
Well, thank you again for joining us today.
Yeah, thanks, Brian.
Please remember that you can find the show notes for this episode and all episodes of the Engineering Quality Control podcast at engineeringqualitycontrol.com. There you'll have resources and links to the information we talked about, including how to get a hold of Eric. Until next time, friends, I wish you the best in all of your engineering endeavors.